Alrighty. G'day. How are you all? I sound like I'm booming. Am I deafening everyone in the back of the room? No, it's okay? Okay, good. So this talk's called From Rails Rumble to 50 million results. Isn't that an awesome number? In fact, we're even bigger now. It's now 65 million, but for some reason, they didn't want to reprint all the programs for me. I reckon that's just slack and lack of foresight. But that, of course, means that I can say that we're enterprise now. So now I've got all of the basic keywords out of the way, I'll start the talk. So first off, I'll just tell you who I am a bit. You may or may not know who I am. I started a company called Reinteractive. We're a development shop in Sydney. We've got about 13 people now, I think, spread all over Australia. In fact, 3 of them are here. We don't actually have an office, so we run everything remotely, and all of our developers live and work from home. And we only actually catch up once every month or so, so this month we decided to meet up in Austin. So it was a long flight, 30 hours, but it was a good team meeting, so that was good. We also started stillalive.com, which is what this talk's about, which is a web monitoring service. I wrote the mail gem. That's my claim to fame. Mail was really funny because when I first started writing it, I was doing this application that used Tmail. Who's here has used Tmail? Yeah, I'm sorry. So Tmail was awesome in that it existed and it worked mostly. But there was this great quote from Mike Kozowski, and he said that Tmail was really good at detecting spam because all you needed to do was wrap Tmail in a begin rescue block, and if it crashed, it was probably spam, and then you just delete it because it couldn't handle malformed emails. This wasn't working very well for what I needed out of mail, so I decided to write a mail gem, thinking how hard could that be? Anyway, there's 24 RFCs that you have to go through to get mail working, and it took me 2 years, and then we got it written. But my most proud achievement is that next one, who I found out last night at Ignite Rails Conf, that my net contribution to Rails, even though I'm like in the top 20 committers, my net contribution is minus 24,000 lines of code from the Rails code base. And I'm so happy about that. I mean, that just rocks. So yeah, I'm a Rails commit team member. I'm a self-taught developer. I didn't really do much computer science. And I tell you, I did a business degree at uni, right? Going from a business degree to writing parsers for email is like about as vertical a gradient as you want to do in computer science. But it was a lot of fun. I blog at lindsaar.net. I tweet at Lindsaar. Feel free to ask me any questions. So what's this talk all about? This talks about how you bootstrap a startup on the side. Okay, we've all got our jobs. We might even work for companies that have startups that they want to do on the side and how they get that running. And there's some pain points involved in that. And this is going to talk about how you go from 0 to a lot more than 0 and how you get there and really produce it into an application that's actually working. The talk's going to be more than just technology. I'm going to go over a few technology points. Obviously, we're going to go over some database stuff, some pain points we ran into there, some stuff on queuing, some other things like this, but it's going to be a generalized talk. Where do I get this data from? Mainly, it's from when we screwed up and the application servers crashed. So I want to try and impart some of that knowledge to you so that you don't also have that sort of a problem. And when they do crash, because any app will, how you can mitigate that and how you can make sure that you can recover from it quickly and get back into action. Also my own practical experience, because we've got Reinteractive, it's a development company. We do a lot of Rails maintenance and support of Rails apps that we didn't build. We look after many Rails apps. So there's a lot of practical experience there from what happens with client apps, which we were then able to fold back into our experiences with Still Alive. And then also my hard-won knowledge. So first off, I'm going to give you a little bit of a description of what Still Alive is so that we're all talking on the same page, so you know. Does anyone here actually use it? Ryan, you're awesome, but you don't count. Who's that? There was a hand. Yay, you're awesome. So what Still Alive is, it's our attempt to help you do this, which is catch every bug on your website before your users do. That's a pretty big statement. But what we actually do is we do live tests against your full stack production environment. So we're not just checking that a front page is up or anything like that, but we're doing a live production test. And probably the best way to explain it is a really short video.
You have a website. It's an online store, selling pictures of cats. It has a lot of complex moving parts, each of them working independently. But what happens when a part of it breaks? It may not be immediately noticeable. Your site may even look like it's functioning correctly, until you find this in your inbox. So what's a person to do? A simple ping check won't stop this from happening again. That's why we created Still Alive, a website monitoring tool that tests the individual features of your website, not just whether a user can see a page. So you can be certain that whenever anything on your site breaks, we'll let you know before your users do.
So really simple, hey? I mean, how hard could that be? All we're doing is running like Capybara against an external website. I mean, that should be easy, right? Just, you know, when I go to google.com instead of when I go to example.com/mypath. Anyway, we thought it would be really simple. But what does production testing mean? Well, it's really a smoke test of your production environment. You're obviously not going to run your unit tests through Still Alive. If you did do that, let me know and I'll send you a free membership for a year. But it's really about smoke tests, and it's following the common application paths, the things that are going to test all the layers of your stack. So a lot of you, if you run a production site, you probably have some service like, I don't know, Web Ping Kingdom or something that checks your websites online and, you know, your front page has got a H1 tag on it, and that's all good. But in the modern days of web browsers and web applications and caching layers, quite often your homepage will come up and your database can be out to lunch. So it's not until you try and log into your app that you find out that, well, actually the session table's full, or you've run out of space to be able to save a new image, or something like that. And that's what Still Alive's designed to catch. It's these full stack tests. We have people doing shopping cart checkouts with Still Alive every minute of every day using a dummy credit card number. We have people doing signing up to their service every minute of every day with a dummy user ID. We have people doing things like go in and navigate around my entire dashboard and all the major screens to make sure nothing 500s, right? And these scripts are only like, 15, 20 lines long, because when you think about it, a modern web application, when you're using it with a customer, there's a couple of happy paths that all customers are going to do. They're the sort of things that Still Alive can handle. We also do deployment testing in that when you push a new set of code to servers, the first thing you really want to do is, did it break anything, right? And a lot of people will get on there and just start clicking around as a developer. It's useful, it's better than nothing, but it's very random. So we've got people, they use Still Alive as a smoke test post-deployment. So the deployment's happened, it's blown up, they get alerted, they can roll it back. In about 3 weeks to a month, we'll be releasing an API callable part. So what you'll be able to do then is you'll have, say, 5 or 6 app servers running. You pull one app server out of the cluster, you upgrade it to the new code base, you ping Still Alive, it runs the scripts on that specific host, and if that's all okay, it returns okay and your deployment can continue. If that returns false, then your deployment can roll back, and that can fully automate it. So then you don't have this fear of hitting deploy on your website anymore, you can just deploy it. And yeah, thanks. So you can just deploy your site, you fully automate it, and then basically what will happen is Still Alive will say, no, you can't push that out live. When that comes on live, we've got a lot of demands for that, so that'll be up soon. Where did it come from? Well, we actually needed it as a solution for our clients. As I said, we monitor a lot of people's websites, so clients really love it when you email them and say, by the way, your site was down for 3 minutes today, we fixed it and it's all good. They really like that. And Rails Rumble was coming up. So what we did was we decided to build Still Alive in Rails Rumble, and this was a triumph. And I've made a note here to say that it was a huge success. And if anyone understands the Portal song, I'm really surprised that no one got that. Did no one you got that? You know the Still Alive song, this was a triumph, I made a note here, huge success. If you haven't played Portal, if there's one takeaway from this talk, go play Portal. The technology that we use is Rails 3. We have these workers which check the websites. They were using Capybara Mechanize. We've now got them running on Capybara WebKit. They're very forked versions of those, but that's what they are. And our queuing is being handled by ZeroMQ, and we're using Chef for configuration. I'm going to go through all of those now. So the first part I want to talk about in scaling your startup. So we're not talking about a startup here where you've gone and got $14 bazillion from 15 Archangels, and now you want to produce, an online store selling pictures of cats or something. We're talking about how do you get your startup that you've got running on the side, the project you've always wanted to do, how do you get that up to a point where it's profitable, right? And that's what Still Alive is now. The first thing I found is you have to really start simple. And it's critical that you start simple. And part of the really cool thing about doing our initial launch, our initial coding out of Rails Rumble, is it forced us to be simple. Who here has participated in a Rails Rumble? Yeah? That's it? They are awesome. Does anyone not know what a Rails Rumble is? A few? Okay, so a Rails Rumble is basically, it's 48 hours, and you get a team of 4 people together, and in that 48-hour period, you have to design, code, and release an application that does something useful, right? You've got 48 hours, and it's a competition. And then all the people that enter get rated about how complete their application is. And some really cool apps have come out of this. So we did this 2 years ago, and we got it done in 48 hours. And what it does, though, is that when you have 4 people working on it for 48 hours, you only really get about 130 hours of development. So what that forces you to do is really get tight down on what your core features are, right? And it forces you to only focus on those core features. And so when you're starting your startup, if you do have this idea and you want to get it rolling, the best thing that you could do for yourself is set yourself a hard deadline, and it's releasing on that date, come hell or high water. And you just get it out on that date. And what that will do by setting that date is it will start a mental process in your head where you start rejecting features which are too complex and too fluff, and really focus you down on what's important. The other thing that Rails Rumble told us was that at the end of that Rumble, when I say we built Still Alive in 48 hours, we did. We built it in 48 hours, and I've spent the last year and a half fixing it, right? But what it did do was it worked mostly, right? It was pretty good. But what it really did was it validated us, because we got hundreds of users in that first week. Like, so many people signed up on it. And we started getting feedback instantly, and the things that we thought important weren't really important, the things we didn't really think about were important, and then we could really focus. Which brings us on to the next bit. You have to focus. So once you've got this core basic system out, what you then want to be doing, and what we did when we're talking about feature scalability, is focusing on the core features. So for us, the core features of our app are, does the worker work? So the worker in our app is the thing that actually goes and tests the website, right? Pretty critical piece of the application. If that doesn't work, basically we're screwed. So we pour a lot of attention and detail into that. In fact, we've just done a spike of development where I've had myself half-time and one of our devs full-time for 5 weeks, basically full-time, just on getting new features into the worker. And at the end of that sprint, basically the front-end users won't see anything has changed on Still Alive, but it'll be a much better, more advanced worker. And then the other things that are important to us was the stability of the site. The last thing you want when you've got a monitoring service and you're paying for it is to go to the monitoring service and the site's down, right? That's not good. That's happened a couple of times to us, and we get really interesting emails. It's like, hi guys, just thought you might like to know you're down, doofus. And then the other thing, of course, is false alarms, because the next worst thing you can do is wake someone up at 3 a.m. telling them their site's down and then go, oh, just kidding, sorry, whoops. So to give you an example on focusing on worker improvement, one of the things we just did was take Capybara Mechanize out and put in Capybara WebKit. We're doing it as a parallel test. I was really hoping to get it launched today. It's not quite there. It will probably go online tomorrow or the day after. But what that gives us, of course, is a full JavaScript testing ability. So you can use Still Alive to check your Backbone app. It doesn't have to be a HTTP request. It can handle everything. So one of the things we found on that was we started doing Capybara WebKit. And of course, Capybara WebKit goes, oh, well, you probably want this half gigabyte ad from DoubleClick because you probably want to assert that the double-click ad is appearing on the page. And our traffic on our utility boxes was like this on Mechanize, and then we turned on WebKit and it just went because it was pulling down all the external dependencies, it was pulling down all the typekit fonts, it was pulling down all the images, and you multiply that by a couple of thousand sites per minute being checked, it was quite a lot of traffic. So we actually just pushed a fix back up to Capybara WebKit. I think there's a pull request with the ThoughtBot guys, that there's a flag now that you can turn off image loading. The other thing we did was added blacklist URL support. That was a fun problem. We started testing all of these servers because we ran all of our stuff in parallel, right? So we've got our mechanized workers running, then we fired up all of our Capybara WebKit ones in parallel to make sure that the results were the same, because we didn't want to turn it on and then everyone gets false reports, right? So we're running them in parallel. We didn't really tell our users this because, you know, who's going to notice? It's just an extra request a minute. No one's going to really care, and we just want to check it. Anyway, we got about 15 emails saying, what the hell are you guys doing? And we're like, what do you mean? Well, what had happened was because we're now doing JavaScript, the WebKit server was now loading all the analytics files. So everyone was getting 1,500 to 3,000 to one person was getting 10,000 hits per day showing up on his analytics. He wasn't very happy about that. Although his boss originally was really excited, saying, oh, good, what's happened? You know, then he had to explain, actually, it's our testing service. And anyway, that wasn't good. So we've added blacklist support now so that Capybara WebKit, you give it a list of URLs that it will just never visit. So we put things like the Google API one in there. We're also putting all the ad servers like DoubleClick and stuff so we don't pull all those down. And then reliable timeout handling was another problem that we had. And this is just an idea on focusing in on what's important to your project, right? So WebKit doesn't do timeout handling. I mean, it does. But if you ever clicked a website with a bad net connection, how long does your web browser wait until it says it can't reach it? It's like 10 or 15 minutes or something crazy. Now, if you're testing 1,000 sites and one of them turns off, then that worker now won't do anything for 15 minutes while it waits for WebKit to time out, which is not useful. So we hacked that in and we're setting that up as a pull request as well. But these are points where you're focusing in on the core functionality of your service. Spend time on that. The other important part when you're scaling the features of your site is to engage with your customers as much as you can. Now, obviously, if you don't have millions of dollars, there's only so much that you're going to be able to do in terms of engagement because you've got your day job or you've got whatever else. But the key is to just be in communication with them. So if they say blah blah is not working, send them an email and say thanks for letting us know. We'll get to it as soon as we can. But as long as you're in communication, that's going to be so much better than not. The other thing is, don't just implement everything that everyone wants instantly. That's death. What you've got to do is really choose your targets and choose the ones that give you the highest bang for buck. You don't want to just blithely introduce everything, every feature that comes along your way. So it's a bit of a curator role. You know, someone wants feature A, okay, thanks, I got it. If you can implement it straight away and it's along your development path, go for it. But you have to make that judgment call. So next thing I want to let you know about is the other point that we came up was performance scaling in terms of monitoring. So there's several ways that you can scale performance of your site. And if you're not monitoring your site, it's almost pointless doing any sort of performance scaling because you don't know what the problems are. You're just refactoring before anything happens. So we break our monitoring into the following broad three areas. First one is user experience alerts. Now, we actually use Still Alive to test Still Alive. Yeah, we use our own dog food, but that also sounds a bit stupid, right? Because if Still Alive goes down, how are we going to monitor that Still Alive's down if Still Alive's down? Believe it or not, monitoring our own service with Still Alive has found about 5 incredibly hard to reproduce bugs that we've been able to solve. So it's good. We use it ourselves. We use it on all our client sites. That also goes back to what DHH was saying this morning, that great tools are made by people that use it, right? So I tell you, one day when we were first getting our monitoring happening, I got woken up one night and they were all false alerts. I swear I spent 2 days doing nothing but fixing that. So I didn't want to get woken up again. Still Alive is good for it's broken type alerts. And this query is taking far too long and timing out your web app. And it's great for my clients going to get pissed off at me type alerts. One of the reasons it's good at that second type, this query is taking far too long, is if you've got a Rails app and say you're hooked up to Airbrake or something, and your query takes so long that your Nginx kills the Rails process, you won't necessarily get an Airbrake alert. It'll just be a timeout, right? And you won't know about it. And the first we knew about this was happening was a still alive alert coming in saying it couldn't log in. And we're like, what do you mean it can't log in? Then we tried it and we could log in. And then it would say it couldn't log in. And then at the same time, we got a user send an email say they couldn't log in. And what we found out was if this user was logging in at the same time that Still Alive was logging in, it would crash and not send any errors. And that's a really screwed up situation to be in because it's almost impossible to find. But because we had this, we found it. And I'm actually going to go over what that problem was later in the slides. The next type of alerts we run are system operations alerts. So these ones are testing really core features about your application. So you don't want to do massive stuff. What we do is we run a cron check, which hits a URL on our application that does a quick internal systems check. And we check 2 key metrics. And the metrics are, the first one is, when was the last result generated by Still Alive? How long ago? And the second one was, how many scripts are waiting to be executed? And if either of those get too big, then we know we've got a problem, and that command starts alerting everyone's mobile phones. And I hope my mobile phone doesn't go off in the middle of this talk. But we do that with cron, and we do it by hitting a URL. Now, that little thing there is a chef recipe to fire up a cron command, if you're wondering. And you can see the command there is just user bin curl and then a URL, right? Now, the reason we do it with a URL is that it means we can hit the full Rails stack without having to boot Rails. So another way to do this that's quite common is like you go Rails script execute or whatever it is, and then you give it a method name to call, and then it will return a result. But the problem with that is it has to boot the Rails stack to run that. And that can take 30, 40 seconds or 50 seconds. And if you're doing it every minute, suddenly you can start overlapping, right? So this method hits a production app server that's already running, that's already booted, and that request happens in about half a millisecond. It just goes boom, and it's done. And if something goes wrong, then the Rails app, the query takes a bit longer, and the Rails app sends out all the SMSs and does all the alerting. But that works. The other reason we use cron to do this is cron is hellishly reliable. I mean, it just doesn't break, right? It's been around forever, and that once we coded that, we've never had to touch it. The other type of alerts and analysis you want to have running on your startup is things like PostgreSQL slow query logs are really good to look at. You can just Google that. You can turn that on. If you're not using PostgreSQL and you're using some other, I dare say, database like MySQL, that's fine. Just change to Postgres. Rails log files are useful, but usually only when you're trying to track down a specific request. But having exception notifications, something like we use Airbrake, is incredibly useful. And obviously New Relic for digging into stuff is very useful. But yeah, PostgreSQL has saved us many times. So they're the broad types of alerts that you need running. So one of probably the lowest hanging fruit in terms of increasing performance on any Rails app, anywhere, is the database layer. You can do, usually, unless your app's not doing a lot of database calls, obviously, in which case, whatever. But usually you can get a lot of performance improvements out of this. And the lowest hanging fruit out of the lowest hanging fruit of databasing is indexing. So in Postgres, there's this command called explain analyze. Who's familiar with that? Okay, about half the room. The rest of you must be using MySQL. So we had a query that was taking 4 minutes. This was the one that was randomly killing our user that was logging in, and at the same time killing us trying to log in. And the reason it was killing it was because it was taking 4 minutes to run, so he kept clicking reload. And then we'd have 12 app servers all trying to do a 4-minute long request against a database server that was screaming and yelling and trying to die quietly because it just couldn't handle the load. So I'm going to show you what this 4-minute query was. That query there, select started at, ended at, success from results where result ID equals 1, order by created at, descent limit 50. That was taking 4 minutes to run. And it's not fair that that was taking 4 minutes to run because we had 2 indexes on the table. We had an index on site ID, we had an index on created at. So what the Fill your own expletive in here. This was really confusing when I first looked at it, because I know a fair bit about database queries, but I was sure that that had a problem. Does anyone in the room know what the problem is? Don't yell it out, just raise your hand. Yeah? Good. 2, 3, 4, 5. So it's not many people, right? So what explain analyze lets you do is prepend any query with the words explain analyze, and what Postgres will do, it will then print out how it came out about working out what the query planner execution is for this bit of SQL. And it's pretty small, but on the third line from the output, it says it's going to do an index scan using index results on created at. Good. So it's going to use the created at index. And that makes sense because it's going to do, this results table, by the way, is 30, at the time we did this, was 35 million rows long. So doing it on created at made a lot of sense because it knew it only had to get 50 results, and the table had been around for 1.5 years, and the query planner looked at that index and went, well, 50 results would have happened in the last, minute, so that's going to be a very small subset of that table. But then the kicker is that underneath that, it then goes filter site ID equals and a number. Now, the problem is that site ID equals a number is not using the index. It's not using the site ID index. So what ended up happening was a full table scan of 30 million rows on a database that didn't have enough RAM to keep that table in RAM, plus the index at the same time. So it had enough memory to hold the index in RAM, but not enough memory to hold the index plus the table plus the other indexes. And what basically happened was it loaded up the entire 1 gigabyte table into RAM plus all of its other stuff, right? And then it just went into swap. And then, of course, the user, being ever helpful, clicked the link 12 times and the whole site just blew up. In fact, I SSH'd into the database server and it took 7 minutes to give me an SSH prompt, which I think is my personal record. The solution was, well, if it's only using one of the indices, give it an index that's going to give created at and site ID. So the solution was add index results, site ID created at. And that just made a compound index, and that reduced the query from 4 minutes to 0.448 milliseconds, which is, I think, 500,000 times improvement. So I was pretty happy with that result. But now you can see you can do the same explain analyze on the table, and it's got that it's doing an index scan on results, site ID, and created at, and it's got an index condition, not a filter at the bottom. Index condition, site ID equals blah. So now it's just gone boom, and the result comes back. And it's actually quite a testament to SQL when you consider that you're doing a query on a 40, 50 million, 60 million result table, and you're getting a result in 0.448 milliseconds of 50 rows. That's pretty fast. But this hit another problem. How the hell do you add a new index to a 60 million row table that's getting about 2,000 inserts a minute or more? Because what happens when you index a table? Does anyone know? It locks. It won't let you add or delete any more records until that index completes. So what that will do is your site goes offline. So you've got two options. Well, you've only got one option if you're not using Postgres, and that is you just go, we're down for like an hour while we update our index. So luckily we have another solution. We have the technology. And in Postgres, you can do concurrent indexing. Who's heard of this? Okay, good. Probably the same people that can tell me what was wrong with the last query. Concurrent indexing is awesome. What it lets you do is you just insert the word concurrently on the normal indexing statement, and it will build the index in parallel to your database running. And the way it does it is it does 2 full table scans of your database. It does, of that table. It does a first table scan and builds up the index. And while it's doing that, it's recording a log file of every transaction that's happening on that table. And then once the index is built on that first snapshot, it then plays back all those transactions and then does another table scan. And it means that you can add a massive index to a massive table without taking your database offline. And that's really cool. The problem is it takes a lot longer to run. It's not double the time, it's more like 3 to 4 times the time. So if this database running on a box by itself took about 45 minutes to build, so when we did it in production on indexing concurrently, it took close to 2 hours. However, for that entire 2-hour period, we were running, and we were not having any problems with our users. So that's pretty good. The other thing is you can't do this in a Rails migration. Don't try it. The reason for that is all migrations run within a transaction block, And this, by definition, is doing itself in a transaction, so it sort of conflicts and it just breaks. Postgres will just throw an error and it crashes. So you just have to you log into your server, open up a screen session, get into your SQL console and just paste it in. The other really useful thing of concurrent indexing is if you need to re-index a table. See, the problem with re-indexing a table is it's going to do the same thing. It's going to lock your table. You're not going to be able to do any reads or updates. So if you need to re-index something, you can create a new index with a different name, just call it same index name with a 1 on the end, give it the same constraints, build it concurrently, and then drop the original index, would be a solution. Although Postgres 9, I haven't found a situation where I've had to re-index, but it was an old problem. The next thing that we hit that was a problem was our queuing. Does anyone here use queuing in their apps? Yeah, it's a common problem. So our old queuing system, and in fact it's still in place a bit now because I didn't get a chance to finish it. We're cutting over to our new queuing system at the same time that we're cutting over to Capybara WebKit. Our current and old queuing system use delayed job. Now, delayed job is awesome in that it works, it's simple, and it gets you up and running. And it's really the simplest thing that can work. And that's what we got running during the Rails Rumble, and it worked. And it's been working for 1.5 years. The problem with delayed job is that it's really heavy. So usually when you're running delayed job, you're going to boot the Rails stack. So that means each delayed job worker of ours was basically consuming 450 meg of RAM just to boot. The other thing is it needs a direct database connection. And this is the same problem that's shared by Rescue and almost every other queuing system out there that's not like RabbitMQ or something. And these direct database connections were causing problems for us because what we wanted to do was have our workers distributed around the world on cheap servers wherever we could put them and not have to worry about, oh, now we're going to have to build a VPN tunnel across blah and keep that running and all that garbage. So the old queuing system looks like this, right? You've got a Rails app, database, and a bunch of DJ workers. The problem is that they were all taking 2.4 gig of RAM and they were only getting 6 workers running on each of those boxes. They all needed direct database connections, which means the Postgres server had to handle 18, 24, 36, however many connections we had of workers running simultaneously. And basically, each one of those boxes was a high CPU medium on Amazon. And that, no profit for you. So then I went, okay, this sucks. And at Rails Camp, that's what this t-shirt is, it's a Rails Camp t-shirt. Rails Camp is what we do in Australia instead of Ruby conferences. Basically, a group of people about this big gets together and codes and gets drunk. And Ryan can tell you all about that if you want to ask him later. So the new queuing system, I wanted to get a new queuing system that worked. I wanted to distribute the workload into small gems that just did one thing really well. I wanted to distribute them along multiple hosts, and I wanted these things to only be about 100 meg each. And we looked around, and basically the model that I wanted to do was something like this. I wanted a database which had a publisher which published the jobs, a worker that did the work, a parser which actually went to the websites and checked it out, and then a sink to drain all the results into. And then the way this works now is that basically a worker contacts the publisher and says, hi, I exist at this IP address running this version. The publisher goes, thanks for that, and records that data in the database. And that gives us a database screen on our admin backend. We get every IP address of every worker that's running, what version they're running, what the PID is, what host they're on, how many jobs they've done, when was the last time we heard from them, all of that sort of stuff. We're actually about to program in something that allows us to kill a worker remotely from the admin console, tell it to reload. But that's pretty cool. The publisher then gets the next job and updates the database and say this job's running and sends it off to the worker and says, here's your job. The worker then works with the parser to get that job executed, fires it back to the sink, which then publishes it back into the database. So this functionality is what we wanted to get running. And if you look at that, there's basically 2 queues there. There's a queue between the publisher and the worker, and there's a queue between the worker and the sink. And we wanted to get those queues running. Now, you will notice that there is no messaging hub in the middle of that, right? Traditional queuing systems have this, like RabbitMQ or Beanstalk or AMQP, these ones, they have this central messaging hub which has to sort of exist and run, and you send your messages into that and then it brokers them out to all the workers, right? I didn't want to do that because I'm lazy. So I hunted around, and on a recommendation from a friend, I looked up ZeroMQ. Has anyone used this? Yeah, isn't it awesome? It's so fantastic. What ZeroMQ is it's a socket library for network ports. So you would all be familiar with sockets because when you run, because more than half the room was using MySQL, so no, Postgres does it as well. But you can have a socket and you connect to your socket and you just put data on the socket and it arrives at the other server, right? That's what socket programming is. What ZeroMQ does is it turns a network port on any transport layer that it supports, including TCP/IP and LDP and all these other ones. It turns that network port into a socket. And then what you can do is you can have multiple workers subscribe to that socket. So then you put a job on that socket and it just goes out to the first worker. And there's no polling. And that is awesome. Because then you can just add 1,000 workers. And all they do is they just make one connection to the socket and they say, hey, I'm here. And then they just sit there and wait. And then as soon as a packet arrives on that socket, it goes out to the first worker that's available. So this no polling thing was fantastic for us. The other cool thing about ZeroMQ is there's nothing in the middle. So you've got the publisher, and you've got all the workers, and then you've got the sink, and they all just talk to each other, and it all just works. And it's pretty amazing. And I'm going to show you a quick demo of how that goes. It's going to be a very quick demo. This is a basic script that runs. This is the ventilator. So this is the publisher. This is the thing that's sending out the messages. And really running this in Ruby is just a matter of requiring the ZeroMQ gem. Then you can create a context. Contexts are not thread safe. You can only run one context per thread. Actually, you can only run one thread per context. You can run as many contexts as you want within one thread, but yeah. And then what we do is we're just creating a queue here, and we're saying we want this to be a push queue, which means this ventilator is going to push jobs out into the queue, right? We're going to bind it to localhost on that port. And then what we're going to do is loop through 2,500 times and send out a job onto that queue. Then what's going to happen is the worker, which is this guy, is going to do the same thing. So he makes a context and he creates two queues. So the first queue is a pull queue, and that's a pull queue. No. So that's connecting to the same port as this, 5557. So that's going to pull jobs off from the publisher. It's then going to create another queue called a push queue, and it's going to connect to 5558, and that's where it's going to send the results. And then all it's going to do is loop. So while true, it's going to receive something off the queue, it's then going to do something with it, and then it's going to send finished to the sink, the results queue. This receive string command is a little bit non-idiomatic Ruby, and if you're going to try ZeroMQ, this stumped me for a little bit because I couldn't figure out what the hell it was trying to do. What that's actually doing is this. It's the equivalent of this. That's how you'd normally write it in idiomatic Ruby, right? We're going to assign the result of getting the next string off the receiver and insert it into that variable msec. What this does here is msec, that variable, gets modified by that function, by that method. So msec here is getting set to the result of this receive string call. If you don't realize that when you're first starting with it, you pull your hair out for a bit because you're going, why are my variables getting changed? And then this is the sink. So what this is doing is it's just setting up, I'm going to receive requests, so I'm going to pull them down, and I'm just going to loop over that a couple of thousand times until I get the results. Now the cool thing about ZeroMQ is because there's no big brokering system in the middle, you can just run this on your Mac or your Linux box, or I don't think you can run it on Windows because that's illegal. So we're going to start up the ventilator, which is the publisher, and it's just going to wait when the worker's online. And then we'll start up the sink, which is going to get the results. And then we're going to fire up 5 workers. So we've just fired up 5 workers. They're all running. And they're waiting for stuff to come in. So now we're going to hit enter on this ventilator. And it's just sent out 2,500 jobs. And now we have all 5 workers, each pulling the next job off. And you'll notice it's load balanced those between all 5 workers, which is pretty awesome. Further, there's the sink getting the results back while all this is happening at the same time. And there you've just built a queuing system. Now the cool thing about this queuing system, and there you go, it's taken 24,000 milliseconds to run, and it should have taken 12,000 milliseconds to get, 120,000 milliseconds to get it done. 120,000 divided by 5 workers, that's about what the load balance thing was there. So that's how simple ZeroMQ is to get running. And really, our production server isn't much more complex than that. The only thing we do additionally is that we wait for a worker to become available before we try and dump something in the queue, which allows us to kill and add workers dynamically. So, is it reliable? It's TCP reliable, yeah. Well, it's as reliable as whatever the socket, whatever the network layer that you put it on is. So if you're running it on TCP, yeah, it's TCP reliable. TCP reliable. So the new queuing system is highly scalable. It's a socket library, so there's no polling, which is fantastic. There's lower overhead. We can spin up and spin down workers whenever we want. We can add them at will. And it's resilient to downtime. And the reason it's resilient to downtime is that each queue has a buffer, and that buffer can fill. So if we restart the sync, what we can actually do is we can start a new sync, kill the old sync, and it will just sort of pick up and keep going. And it's magically stable. We did this with custom gems. So what we did was we took the work that the delayed job was doing, and we extracted that out of our Rails app, and we turned it into its own gem, the parser, and then we extracted the whole queuing stuff and turned that into its own gem. And what that allows us to do is we can get a Linode box somewhere, we SSH into it, and if we needed to do it manually, we could SSH into it, we could bundle, like, we could package add or emerge or whatever package management tool we're using, the Qt library, and then we just go gem install, pass it the local copy of the gem, and then once that's finished, we just go run, and it's running. And now we have a worker running on that box, and that's very valuable. And that got us this, which is a distributed responsibility. And each of those workers is now only running a gig of RAM, and we're running 10 workers per box. And what does that mean? Profit for you. So the last stage of stuff I want to go over is process scaling. So one of the things that you get when you're running these companies or things on the side is you want to make sure that you're not wasting your time. And the way you don't waste your time is you standardize standard actions. So the first thing we did was, originally we were running all of our staging servers on Heroku. Why? Because it was cheap. Was that smart? No. But the reason it wasn't smart was not because it was on Heroku, but because our production servers weren't. We run our production servers on EngineYard. And what that meant was we had a staging environment where, I mean, at an application level is the same, but the underlying technology was different. And it never really caught us out in a big way, but a couple of ways, it just meant that you had to change the way you were thinking when you were trying to test something on staging. And if you have to change the way you're thinking when you're trying to test something, it's an indication that you're doing it wrong. So we moved our staging environment back into EngineYard, which has actually been good for us because then we can just snapshot it and spin it down and then we spin it up if we're not going to use it for a week or two. And again, if you're running this on the side, that's quite valuable because, you know, that's $300 you don't have to spend. The application deployment is really critical. If you're running your own little startup on the side, automate this as much as possible and document the hell out of it. And the reason for that is that you will sometimes not commit to your code base for a month or two because you're busy, right? So if you have to come back 6 weeks later and go, how do I deploy this again? You don't want to do that. So we've got ours down to just a single command, and that deploys it to all the servers. The other important thing is get zero downtime deploys happening. You can do that really simply these days. We use Unicorn. So a zero downtime deploy with Unicorn basically works by Unicorn reloading itself, and then once it's reloaded, forking itself again and then killing all the old workers. And what that means is from a customer point of view, they don't see your app go down. They just get to a point where one request takes a few seconds longer to boot. And that's very valuable. And the reason that's very valuable is you can do constant updates to your website without having to tell anyone or schedule downtime. But the key thing on application deployment is you must automate it. The other point was application configuration. So we use Chef for this. EngineYard makes that pretty simple because They use Chef by default. You can do it with Puppet. It doesn't really matter what you do it with, just do it. The reason we get that done on our system is that we have all these different things booting at the same time, and I can show you my, I'll show you what I mean, I think, if I have it running. No, I don't, of course. I can show you later. I was going to show you our engineered panel. But we have 12 or 13 different servers running on EY with different features and different functionality. So if we need to spin up a new script worker, we just go start a new instance of blah, and it just starts. And because we've got everything automated in Chef, 10 minutes later we have a new blah running. And that's very, very valuable, especially when you need to scale or you need to rebuild an instance or that sort of thing. It's a lot more work at the start, but believe me, once you've done it once, you never go back. The other reason that's really cool is, again, 6 weeks, 8 weeks, 2 months later, when you have to get blah running, you don't have to think about it. There was this good definition of legacy code, and legacy code is either someone else's code or any code that you've written that's more than 3 months old, right? And it's true, because if you've written code 3 months ago, you probably don't remember what it does. Not fully, because you're out of that headspace. So automate, automate, automate. The last thing is making sure that you're doing standardization. The more standard you can make any action in a company, the more profitable you'll be. And if you want a proof of this, if you want to go ad infinitum to the extreme, look at McDonald's. I'm not saying that their food's any good, it's not, but they're very standard and they make a shitload of money out of it. Now, you don't have to get to that point, obviously. I mean, like seriously, did you know that McDonald's, on the bun, when they order it from a supplier, they specify how many seeds per square centimetre should appear on that bun? I mean, like, they're nuts standard, but they make a lot of money out of it. Now, I'm not saying you don't want to standardise things like creativity of your staff or design or this sort of thing, but the things that you can standardise them and drill them occasionally. And again, that's why having your staging environment the same as your production environment is very valuable, because you can drill that, you can keep it standard. The other thing to standardise is things like deployments, commits, and branching. So we use Git flow. If you're not using Git flow, there's a blog post for you that says, why aren't you using Git flow? So you should go read that. And we do pull commits on our code base. So then we just have a pretty flat commit model. Any developer can do a pull request, and then any other developer can approve that and merge it in. And that just gives us the ability to be quite dynamic, and it works quite well. So in summary, when you're scaling your startup, feature scaling is the first thing. Focus on key issues. Go for the highest bang for buck. Put a deadline on it and stick to it, and stay in communication with your clients. But the most important one out of those three really is put a deadline on it and stick to it, because that's going to reduce your features to what you actually need to start earning money. Performance scaling. Use the database tools you have, and if your database doesn't have tools, use a different database. Use external monitoring systems like, I don't know, Still Alive. Make smaller, tighter chunks of code. Try and reduce responsibilities on your code base so that when something goes wrong, you can go to the exact area and fix it. You don't have to try and fix a whole Rails app. And try avoid loading up your Rails stack for background jobs. It will just end in tears eventually. Process scaling, dedicated staging environment. Make it as close to production as possible. Continuous deployment, configuration management, and automation. And then any questions? The last point is that I've got a 30% off promo code. If you go to Still Alive and sign up for a trial, we'll give you 30% off when it finally ticks over into billing. You get 4 weeks. So on that note, thank you very much for listening to me for the last 45 minutes, and I'll open the floor to questions.